Okay, so matrix lesson 6. Why we are learning how to do all this stuff. Why we are learning how to multiply and scalar and find determinants and find inverses. And the whole reason behind this is so that we can use matrices to solve. Okay, solving systems. And again, 2 by 2, that means, a 2 by 2 matrix, 2 rows, 2 columns that deals with 2 variables, you will do by hand. Anything bigger than that, you will put in the graphing calculator. And the last lesson in the matrices unit will be teaching you how to use the calculator. Okay, so this is something that you would have done freshman year, probably junior year as well. Okay, so we have our system of equations, right? 3x minus y equals 7, 2x minus 3y equals negative 14. And you would have had to either graph them or solve them by elimination, which means you would have had to multiply one or both equations, right? Okay, so we're going to make this system of equations into a matrix equation, okay? And it involves 3 things. You have to have a coefficient matrix, a variable matrix, and what we call our answer matrix, because technically it is the answer to these 2 statements right now. Okay, even though it's not the answer to the problem. So your coefficient matrix is exactly what it sounds like. It's the coefficients from all 4 of your pieces here, and including the signs. Very, very important. So 3, negative 1, 2, negative 3. Okay, our variables are x comes first and then y, and these do need to be written in order of how they're written in the equation. And here's why, and I'll show you. So these are technically being multiplied, right? And then your answer matrix is 7, negative 14. Now, if you remember your multiplication rule, multiplication is going across the rows and down the columns, right? So if I were to actually multiply this or write this back, take this matrix equation and write it back as these type of equations, the system, it would be 3 times x as your first piece, minus 1 times y as your second piece, equals 7, right? And you would be able to rewrite this right back as a linear equation. It's actually pretty cool. Do the same thing with the bottom, 2 times x, go across and down, it would be negative 3 times y equals negative 14. So it has to be written in this form very, very specifically. Okay, so we're trying to solve for what x and y might be, right? So let's think about this in terms of solving an equation that, say, 2x is equal to negative 10, right? I'm trying to solve for my variable, so I do the inverse of whatever has been done to the variable to solve, right? And in this case, you'd probably say, oh, just divide by 2. Okay, but we can't think of it as that kind of an inverse in matrices. We can't divide by matrices. We can, however, multiply by an inverse. And in this case, the inverse of 2, multiplying by 2, would be to multiply by a half on both sides, right? And what happens here? If I multiply 1/2 times 2, I get 1. It basically cancels itself out, simplifies, and all you have is x left. And here, negative 10 times a half would be negative 5, right? So it's just, this is the reason why we have to have an inverse, because we somehow have to get rid of this. This coefficient matrix needs to go bye-bye, so that x and y would be by itself, and whatever's on the other side would be my solution. Okay? So we find the inverse of our coefficient matrix, which is what you did in the last lesson, because something really neat happens if you multiply them. If you multiply a matrix times its inverse, you get this, which is what we call the identity for multiplication matrix. Because if I multiply by this matrix times anything else, it doesn't change anything, right? Think about it. 1 times x plus 0 times y equals just x, right? And 0 times x plus 1 times y equals just y. It ends up being an identity, so it cancels it out, and you would be left with just your variables. Okay, so the other way that this actually works is whatever we do to one side of an equation, we do to the other. So if I multiply by the inverse here, and it makes this cancel, if I multiply by the inverse of the original matrix here, I should get my answer. Okay, I know that's a bit much to think about, but again, it's really just another type of equation. Okay, so we're going to actually solve this thing by using an inverse. Okay, and we're going to actually go through all the pieces and make sure that you see that it does actually work. So the original problem, again, would be 3, negative 1, 2, 3. 3, negative 1, 2, 3 times xy equals 7, negative 14. Okay, so I'm going to find the inverse of my coefficient matrix. I'm going to go through all the steps that I went through before. You know, you find the determinant, and then you subtract, you know, all that, reciprocate and everything else. Okay, so step 1, 9 minus negative 2 equals 11. All right, so 1 over 11. And my swapped and change, well, swapping the 3's doesn't do anything, but swapping my signs does. All right, so I'm going to multiply that out. So that's going to be 1 over 11 times my swapped and changed matrix. All right, and that's going to give me my inverse. So that's going to be 3 over 11, 1 over 11, negative 2 over 11, and 3 over 11 again. Okay, so this is my inverse, right? That whole thing right there. Okay, so I'm going to copy that so that I can plug it in a couple places. So now we're going to solve this equation, okay? And I'm going to solve it by multiplying by that inverse on both sides. Now, here's the way this works, okay? I can put this in the front, and when I multiply them, they will cancel, and we'll go through that, and I'll show you that it does actually work. If I put it here, I can't put it in the back. Let's think about our rule for matrix multiplication. This is a 2 by 1. I can't multiply that by a 2 by 2. The inner measurements don't work together. So I need to put the inverse in the front of the solution matrix. Okay, so it has to be multiplied in that order. So what I'm going to do is, nope, not that. Let's try that again. I'm going to slide this down so that I can multiply it in. All right, so now I've got another one of my inverses. And that's going to be times my answer matrix, which is 7, negative 14. So this is technically what I'm doing to solve my equation. I am multiplying by my inverse on both sides. Okay? I'm going to copy, and I'm going to put this on a new page just so that we can actually look at it. Okay. So first thing, I'm going to go ahead and multiply this out just to show you that, yes, it actually does work as far as getting that 0 or 1, 0, 0, 1 matrix. Okay? So 3 over 11 times 3. Actually, you know what? I'm going to need a little bit more room just to make sure we actually have that. So 3, that's 9 over 11. And then 1 over 11 times 2 equals 11 over 11, which is a 1. So first piece did work. It is a 1. Okay, so do the next one. That would be 3 over 11 times negative 1, so that's negative 3 over 11, plus 1 over 11 times 3. That equals 0. Okay, and keep going. Negative 2 over 11 times 3, that's negative 6 over 11. And then slide over and down. 3 over 11 times 2, that is 6 over 11, and there's 0 again. And then the last piece, again, row 2, column 2. Negative 2 over 11 times negative 1. Okay, and then 3 over 11 times 3. That does equal 1. So that whole thing, when we multiplied it out, actually equaled 1001, which basically is the identity matrix and cancels because it doesn't do anything to the x and y. Okay? So it does actually cancel all that out. down since we just know it cancels everything out. So 1, 0, 0, 1. All right, so now all we have really over here is just x and y, okay? If I go ahead and multiply the right side, which is the inverse times the answer matrix, I'm going to get the actual solution to my problem. So let's try it. 3 over 11 times 7, that's 21 over 11, plus 1 over 11 times negative 14, so that's negative 14 over 11, right? Over 11, not over 3. What am I thinking? Okay, over 11. So what is 21 plus negative 14? Yeah, 21 plus negative 14. Should be 7 over 11. Okay, now let's do the bottom. Negative 2 times over 11 times 7 is negative 14 over 11. Having so many problems here. Over 11. And then 3 over 11 times negative 14, that's going to be negative 42 over 11. Ow. Okay, well, negative 14 plus negative 42 over 11 is negative 56 over 11. Now, yes, the answers seem really, really gross, and that's fine. It does happen. Let's plug them back in and show you that they do work. Okay, back to the original problem. So, one of the original equations, 3x minus y equals 7. Okay, so 3x minus y equals 7. I hope I didn't screw up anywhere because that would be kind of embarrassing. 9 minus negative 2 is 11. 1 is 3 over 11. 1 over 11. Negative 2 over 11. Nope, 3 over 11. Everything's right. Okay, so let's make sure we're going to plug the answer in that we got and make sure that it actually works. So 3 times 7 over 11 minus negative 56 over 11, and it should equal 7 if we've done it right. And I don't think it's going to, but let's check. 21 over 11 minus a negative is plus. 56, oh, it does work. 56 over 11 equals 77 over 11, which is in fact 7. So despite the fact that the answer came out really ugly, it is actually the answer to the problem. Okay, and we can plug it into the second equation and prove it again. Now, most of the ones that you're going to be doing are not going to have fractional answers that are that ugly, I promise. Even the ones on the ACT and SATs are usually not that bad, but it does work. Okay, so we're going to do one more practice, then I'm going to let you go on this one to make sure you're there. All right, so let's see. Example. Oh, my pen's moved. Why has my pen moved? Should be charged completely. The pen's moving, that's bad. It's not supposed to move. There we go. Alright, so example 2. Alright, let's come up with something that's a little bit nicer. Okay, so one that comes out a little bit nicer. And you know what? No, I don't want it to be the same 4 again. I want them to actually change positions. There we go. Okay, so same rule as before. Coefficient matrix times variable matrix, and again the order is very, very important. Equals the answer matrix. All right, so now we're going to go and we're going to find our inverse so that we can actually solve this thing. Okay, so let's find our inverse. All right, so 20, nope, not 20, what am I thinking? That's 12. 12 minus negative 10. 12 minus negative 10. Okay, so that's 22. 1 over 22 times 3, 4. Swap those. Change the others. Multiply it out. 3 over 22 does not simplify. Negative 2 over 22 does. 5 over 22. And then 4 over 22. Okay. So there's my inverse, right? And basically, I really don't need to show on the left that it's multiplying to get 1, 0, 0, 1. We know it is. That's, if we've done our inverse right, that's what makes it cancel. So I'm going to take my inverse, and really, I'm just multiplying it times my answer matrix. Okay, that's all I'm doing. So after I go through the whole inverse, I'm just doing my regular multiplication now. So that's 3 over 22 times 10, so that's 30 over 22, plus across and down 1 over 11. And if I grab my calculator and I add 30 over 22 plus 1 over 11, hopefully I didn't mess up. Hang on. I did. Oopsies. That should actually be positive 4, not negative 1. And the good news is that doesn't affect anything up until what we're doing down here. It should be a positive 4. So let's try that again. So that's going to be 30 over 22 plus negative 4 over 11. Aha. So that's 30 over 22 minus 8 over 22. So that's 22 over 22, and that's 1. So, see, slight mistakes can make really big problems. Okay, so now let's multiply the second one. Sorry about that. Go back and change that to a 4. All right, so now the second half, or second part, 5 over 22 times 10 is 50 over 22, plus 2 over 11 times 4 is 8 over 11. So that's 50 over 22, plus 16 over 22. That's 66 over 22, which is 3. And the original answers that I did come up with were 1 and 3. So go back, check them, just to make sure they do work. 4 times 1 is 4, plus 2 times 3 is 6, so that does equal 10. And negative 5 times 1 is negative 5, plus 3 times 3 is 9, does equal 4. So it does actually work. Okay, and very important also how we write our answers. Since our variable matrix looks like this, it's vertical, we need to go ahead and write our answers as a vertical. So that would be it. So what you're going to be doing for the assignment for this is solving 2x2s. That's it. And I may have you write one out as from a matrix equation to an actual back to an equation by showing the multiplication steps. So, but it's not too bad. It's going to be in section 8.4 again on page 854. Yeah, 854. All right, so you're going to solve 29 and 30, and then you're going to rewrite 33 and 34. Okay, so that's it for solving. The last video for this is literally going to be how to put all this stuff in the calculator, because I expect you to be able to use the calculator for the bigger equations. The smaller ones you just do by hand. Okay, so that will be it for this one.